With number 8, we have big F of x is equal to the integral from 0 to x of root t cubed plus 1, and we need big F prime of 2. So let's start off with F prime of x. Nice and easy, we replace t with x. Now we need F prime of 2, so we replace x with 2. So what do we have? We have the square root of 2 cubed plus 1. 2 cubed is 8, plus 1 is 9, the square root is 3. And finally, we have, on mine it says 8 again. I think on yours it says 9, hopefully. If not, it will for next year's group. We have number 9. Let f be the function which is shown in this graph above. Right? 4 line segments. G is the integral from 2 to x of f of t dt. And we are charged with finding g of 3, g prime of 3, and g double prime of 3. Okay, so g of 3. That's equal to the integral from 2 to 3 of f of t dt. So here's 2. Here's 3. We need the area of the region in between. Right, we've got a trapezoid, so you can do the trapezoid rule. Base of 1. One height is 4. The other height is 2. 2 plus 4 is 6. We want half of that, so we get 3. You could also say 1 block, 2 blocks, and if we flip this over into that region right there, we have our third block. So that would work as well. Either way, g of 3 is 3. G prime of 3, well, g prime is equal to f, so g prime of 3 is the same thing as f of 3. The function's value at 3, f's value at 3, we go across, we see is 2. And finally, we need g double prime of 3, so that's going to be equal to f prime of 3, which is the slope of the line tangent to f at x equals 3. Here's our point. We need the slope of the tangent line. The tangent line is the actual function itself, so we need its slope. We can clearly see that this line goes down 2 and over 1. So the slope is negative 2. For part B, find the average rate of change of g on the interval from 0 to 3. Okay, that's some old material there. G of 3 minus g of 0 over 3 minus 0. G of 3 we already found. It's equal to 3. In our denominator we still have 3. What we need to determine is g of 0. So if we head back up here, okay, g of 0 is the integral from 2 to 0 of f. Now that's backwards, so it's equal to the opposite of the integral from 0 to 2 of f of t dt. So we're taking it, let me change colors here. We're looking for that area, 0 to 2. That's a triangle, base of 2, height of 4, so we have negative 1/2, 2 times 4, which is 8, negative half of that, it's negative 4. So g of 0 is equal to negative 4. Heading back over here, we are subtracting g of 0, which is negative 4. Which means our final answer is 7/3. But again, you could have stopped right there. Part C. For how many values of c between 0 and 3 is g prime of c equal to the average rate found in part B? Explain your answer. So we're looking at the idea that g prime of c needs to be equal to the average rate found in part B. Alright, so our average rate is 7/3. G prime, we know that that's f. So basically it's asking how many different values c between 0 and 3 is f of c equal to 7/3. Let's go back to our picture here. A little bit more. All right. 7/3 is 2 1/3. So that's this line right here. And they're basically asking, how often does f intersect with that line on the interval from 0 to 3? Well, they intersect one time here, and then another time there. Because again, x is starting at 0 and ending at 3. So it intersects twice. So our answer is 2. 2. All right? And it says explain your reasoning. Right? Because g prime equals f, and f of c equals 7/3 2 times on the interval from 0 to 3. And finally, find the x-coordinate of each point of inflection on the graph of g on the interval from 0 to 7. Justify your answer. So point of inflection for g, right? G has a point of inflection when g prime, which we know is equal to f, changes from increasing to decreasing, or from decreasing to increasing. That's our region. So we've justified the answer, now we just have to get the answer. We're looking for relative extremes in our graph of the derivative. Here's our graph of the derivative. There's a relative max up there, and a relative min down there. So the x-coordinates are 2 and 5. Back to our region here. Find the x-coordinate of each point of inflection. X equals 2 and 5.